Okay, this is the example of application of conductivity probes. Conductivity probes indicate that rinsing has been successful once the conductivity of the rinsed water falls below a specific threshold or value of the conductivity. The conductivity of purest water is about 0.04 microsiemens. This is a specific conductivity at 20 degrees Celsius. This is the unit for conductivity, Siemens per cm. This is Siemens per cm. This is microsiemens per cm, and this is millisiemens per cm, and this is microsiemens per cm. So the measurement is 0.04 for pure water, and then if you have top water, soft tap water, so it's about 180 microsiemens. Hard tap water contains a little bit of salt material, like calcium carbonate, so you have about 460. Saline water with natrium chloride, 750. Brackish water like seawater, 2000 microsiemens per cm. You have soda solution, natrium hydroxide, 1%, 12,000 microsiemens. And then if you have soda solution, you have natrium hydroxide, 1%, become 47.5 millisiemens. You have natrium hydroxide solution, 2% is about 90, and then 3%, 127 microsiemens. So this numbers is very important if you measure the conductivity of water. If you still have conductivity measurement values, then the water is still not pure. So you need to do the rinsing more. Okay. So this is the graph of weight of natrium hydroxide against the conductivity in terms of millisiemens. Concentration and conductivity of natrium hydroxide at 20 degrees Celsius. It is increasing over the when you increase the percentage of natrium hydroxide, you will increase the value of conductivity. Not in a straight line, but in a curvy manner. Influence of the temperature on conductivity, yes. That's why you need to do the measurement at one temperature, for example, at 20 or room temperature, 20 degrees Celsius. So if you increase the temperature for 1%, for example, it will increase from 47 to 93 and to 107. Increase the temperature will increase the conductivity values. Components used for cleaning inside tanks. What are the components of the equipment? So you need to remember that you need a spray balls with different types. They must generate about 30 to 50 liters of liquid per minute, per meter. Rotating jet cleaner, different size of fan shaped nozzles, and rotate slowly inside the tank. Liquid film runs down the tank wall in spirals, and the effect of pulsation or pulse operation. Rotating jets can generate high specific liquid impact on the tank wall at a low total consumption. So you can spray with a low volume with the same effect. Orbiter cleaner, different types of orbiter cleaners operate at high, medium or low pressures and come with or without an external motor. Sometimes you can just use gravity. They provide narrow planetary scanning of interior surfaces of tanks and large containers. Okay, this is a photo of different spray devices. If for simple application, Yeah, you can use spray balls run at relatively low pressure, 1 or 2 bar. So these are these are the spray ball with 3 type of sizes. Okay, this is a fixed spray balls and rotary spray head. You have a spray ball and then you have rotary spray head. This will be rotated. Yeah, this thing will be rotated. High degree of fouling or large diameter of more than 3 meters. So you're going to use rotating jet devices run at higher pressure of 5 bar. You cannot use spray ball. Vessel with top mounted agitators. You have 2 spray balls to overcome shadowy part or shadows cast by the agitator shaft and blades. You have shaft of the agitator shaft here, so it will shadow certain parts. So that's why you need to put 2 spray balls, so that all the area inside the vessel will be covered. Thanks for collecting cleaning solutions. Thanks for cleaning solution and disinfectant. This tanks store cleaning solution for all CIP circuits that operate simultaneously. Freshwater tank, you need a freshwater tank. Separates the CIP system physically from the water mains. Must have capacity to supply all CIP circuits that might be running at the same time, with their water levels falling to not less than 1/3 full. So water must be always there inside the tank. The fresh water in the tank must be used as soon as possible to reduce the risk of contamination. So you don't keep the water inside the tank. Return water tank. This tank collects water from the intermediate and final rinsing steps, holding it ready for the next pre-rinse. You don't want to throw it away because it's still usable, so you can use that. The tank must be large enough to cope with the volume of water being used in the rinsing steps that supply it. Task for storing detergent concentrates. Yeah, you have to do a concentration of detergent. Detergent might be in the form of a powder, solid powder, and you have to create this concentrate. Must be type tested, installed and maintained only by an approved expert company. So you have to control the staff that have access to this chemical. The tanks must be closed, should not be operated under pressure, and should be protected against mechanical damage and freezing. And then we go on with cleaning out of place, COP. Okay, several types of method of COP. Mechanical cleaning, utilizing shear force caused by scrape with brushes, sponges, etc. This is what we do when we clean our dish. Jet cleaning, utilizing pressure caused by water jet. Foam cleaning, flushing foaming detergents to make stable foam on surface, prolong contact between detergent and surface, maximizing detergent contact area. And then we can also use ultrasonic cleaning, utilizing cavitation caused by strong ultrasonic wave applied to liquids.